Today we are going to test which brand of paper towel will absorb the most water. The way that we're going to do that is by testing 3 different types of paper towel or brands of paper towel. Brand A is going to be the store brand of paper towel. Brand B is going to be Bounty, the name brand Bounty kind of paper towel. And then brand C is going to be those good old paper towels at school. And we'll see which one absorbs the most water. Now, how are we going to conduct our experiment? Well, the first thing that I had to consider was I needed to make sure that I was controlling certain variables so that the only thing we are testing is going to be the type of paper towel. That's going to be our independent variable, the type of paper towel. We have 3 different types. So the things that I was controlling, number 1, I wanted to make sure that I had the same size for each one of the types of paper towels. So I did that to make sure that they were all the same size. That is one control. Another control is that each time I do a trial, I have the same amount, I'll show you down here, the same amount of water that I'm trying to absorb. Each one of these cups has 100 milliliters of water in it, okay? So those are the 2 main controls. Something that I'm going to try to do my best, but I can't guarantee that it'll be exactly the same due to human error, is going to be the way that I crumple up the paper towel and absorb as much water as I can out of the cup. Okay, so let's get started. Another thing that we're going to make sure that we do is to record our data, and I'm also going to be doing 3 different trials. That's why I have the 3 different cups. So we'll see how that goes. And what is our dependent variable? What are we going to measure? Well, as I go through it, you'll kind of see what's happening, but the idea is that I'm going to take the paper towel, crumple it up. I'm going to then put it into the cup of 100 milliliters of water. I'm going to let it sit there for, 5 seconds. I'll count to 5. That'll be another one of our controls, the amount of time that it's in there left to absorb. And then I will take it out. I'm not going to squeeze it at all, but it's probably going to get a little messy. I'm going to put it right into my trash can, and then I'm going to measure the amount of water that is left behind, okay? I know I started with 100 milliliters. I'm going to see how much water is left behind. That's going to be our dependent variable, okay? So let's get started. I'm going to point this down. All right, so trial 1. Let's stick, this is brand A paper towel. Put that in best I can. 1, 2, 3, 4, 5. Going to remove the paper towel. Try to only let it drip just a little bit. And now I'm going to put it into my graduated cylinder. That is my tool that will help me measure milliliters. I will pour the remaining water in. So 100 milliliters is actually, let me bring this up to this line right here. So that's how much was originally in each cup. You can see that it has absorbed about this much of water. So let me take a closer look. It looks like it's just at, and do you see how I'm getting down to look at the level where the water is? I can't possibly accurately measure it by sitting up. I need to get it eye level for it. So I would say there are 69 milliliters left after brand A for trial number 1. So 69 milliliters I'll record in my chart. Okay, let's move on. Trial number 2. I'm just going to pour this back into my cup. Now, one thing that I did think of with my scientist mind is that ideally we would either completely dry this out in between trials or have another graduated cylinder that was completely dry. Now, unfortunately, I don't have that capability, so we're just going to kind of do the best we can. I'm going to tap it out to get as many drops as I can out and just kind of think that whatever drops are left behind are semi-insignificant, okay, not a huge difference will be made by those little drops that are left behind. Okay, let's do trial number 2. So I'm going to ball it up, stick it into the water, and I think that's 5 seconds. I'll pull this out. That goes in the trash, and now we will measure how much water is left behind. Okay, and hopefully if our results are consistent, if they are precise, we should perhaps get about the same number this time. So let's take a look. Okay, so this time I would say we're at like 65 milliliters left behind, which is reasonable, very close to 69. Okay, we'll pour that back into the cup, tap it, and be ready for the next one. Okay, third trial for paper towel brand A. This is the store brand. Okay, 5 seconds. I drop that into the trash and pour this in and measure it. I get down eye level. I would actually say it's about 65 again. Pretty incredible to have results that consistent. Awesome. Okay, so here we go. Brand A. Those are the amounts that were left behind. Now, Bounty, the quicker picker-upper. Based on the commercial, we would think, hey, this is going to be better. Hopefully this will absorb more. Let's test it out. I'll bring my 3 cups over, each with 100 milliliters of water I pre-measured out. And let's try the Bounty paper towels and record our results. Okay, here we go. So I'll ball up Bounty. I'm really counting on this being much better, friends. Oh, come on, Bounty. 1, 2, 3, 4, 5. Wow, I can already see much less water left behind. Let's measure it. See if we get consistent results, though, from trial to trial. Okay, let's see. I've got, I would say, 52 milliliters left behind. So far, definitely absorbed more. 52 milliliters. I'll record that on our chart. Okay, and move on. Pour this one out. Tap it out. Try and get as much of that water out as possible. And go on to trial 2. Now think about, why might we be doing multiple trials of the same experiment? How would that be advantageous? How would that help us? That's 5. Pick this up, drop it in, and pour our remaining water in. Okay, and wow, I'm amazed. Okay, 51. 51. So last was 52. Now we're at 51. We must be doing a pretty good job of trying to repeat our experiment exactly as we are so that we can get these consistent results. That's good. That means our experiment is most likely valid if we keep getting consistent results like that. And we know that because we're doing repeated trials. If we only did one trial, how would we know if that amount makes sense? Okay, the amount left behind. If we keep getting about the same amount every single time, we can say that our results are precise and valid. 5, okay, pick that up, throw it down, and let's pour this last trial in for Bounty. Measure it, and then record our results. Let's see here, where's my number? I'd say we're at 49 this time. So we'll record 49 on our table. That's how we're writing down our results, our data. Okay, so look at those results. Trial 1, 2, and 3, 52, 51, 49. I would say that's very consistent. And those multiple trials help us to see that. All right, let's get ready for our last one. Oh, friends, we have all experienced the absorbency level of school paper towels. If we have a mess in our class, You often have to call somebody else to get a towel. Okay, let's wipe this up. A real towel, because the paper towels just don't cut it. Okay, so let's see if we can not make too much of a mess here. Okay, school paper towel, trial number 1. Think, okay, how do you think this will compare to brand A, that store brand? These are results so far. The store brand was A, and then Bounty was B. So far, that one's done the best. Let's see what happens. Here we go. 1, 2, 3, 4, 5. Huh. Okay. Pour this in. And let's see here. We've got, say we're at 70. Interesting. 70 for the school paper towel. 70 milliliters for that first trial. 70 milliliters. All right, moving on. Try and get as much of the extra left behind out that we can. Trial number 2. Ball up the paper towel, completely submerge it. 1, 2, 3, 4, 5. Take it out and pour into the graduated cylinder. Sorry. Oh my, this time we are up at, I would say, 74. 74 milliliters for this trial. Okay, so we've got 70, 74. Last trial. Trial number 3, school paper towels. Submerge. 1, 2, 3, 4, 5. Take this out. I'm trying not to let the drips go back in as best I can to be as accurate as I can. Pour this in, and our last one we have, oh my, we are up at 78. I would say brand C was much more inconsistent. I don't know what I had done differently. I'm not sure what I did differently, but we have a difference in our range of 8 milliliters, whereas with the first brand, we only had a difference between 69 to 65 of 4 milliliters. And then brand B, we only had a difference from our minimum 49 to our maximum 52 of 3 milliliters. So for that over here, our brand C to be so drastically different is interesting. I'm not sure what I had done differently. But regardless of that fact, what can you now, what conclusions could you come to based on the amount of water that was left behind by brand A? We're thinking about the store brand. Brand B, Bounty, Quicker Picker Upper, and brand C, our classroom paper towels. Okay, we'll talk about it